Right now we're going to be speaking about the nomenclature, or how to name and recognize haloid salts. Haloid salts are defined by having a metal as a cation and by having a non-metal for an anion, right? So with your periodic table or with your experience or what you've memorized, we can give different examples. Remember, metals have positive valences. That means they give away their electrons. And in this case, some examples, common examples are potassium plus 1, magnesium plus 2, calcium plus 2, sodium plus 1, all of these, right? But we also have metals that have multiple valences, which we'll be talking about later on. And this video is important because it's going to set the precedent so that we can speak about all the different types of compounds. So, for example, we have copper. Copper can be plus 1 or plus 2. That's from another lesson in chemistry, but it's also important for you to know. Iron, which can be plus 2 or plus 3. I'm also thinking about manganese. Manganese can have quite a few valences. I'm going to show you a few of them. Plus 2, plus 3, and plus 6. And basically, any of these metals can serve as a cation part for a nonmetal part. Nonmetals are very simple to recognize. We do not count oxygen in this type of family because oxygens with metals form oxides, so it's something that's different, okay? So we can speak about elements such as nitrogen, which has a -3 valence, phosphorus, which is also -3. We can talk about halogens, chlorine, bromine, iodine, which are -1. These are common ones that we use. We also have sulfur, which is -2, and selenium, tellurium, arsenic, which are also metalloids, because you can also use metalloids to create haloid salts. But basically, any mix that we do with these two is going to give us a haloid salt, right? So what is the naming style for a haloid salt? It's very simple. If we use a metal that only has one valence, such as the ones from group 1 or group 2, and a few notable exceptions such as silver, which is a transition metal but it's plus 1, or the metal zinc, which zinc is plus 2. That means that they only have one valence. The naming style is very simple. We say the name of the metal, metal name, and then we add the non-metal name with IDE ending. Okay? So in this case, let's try an example. We choose a metal which only has one valence, such as potassium. So we take potassium, which is plus 1, and we're going to choose sulfur. Sulfur is -2. We do our crisscross, K2S1, but we simplify into K2S, and we're going to get the metal name. The name of the metal is potassium with a double S. And the name of the nonmetal is sulfur, but since we're going to add the ide ending, we're going to turn it into sulfide with that ide ending, and we're done with this naming style. Metal, nonmetal name, and IDE ending for metals with one valence. Okay? What happens when we have metals with multiple valence? There's a little difference in story because there are two naming styles. So one of the naming styles is, let's take the example of copper. Copper can be plus 1 and copper can be plus 2. And if we take a non-metal such as chlorine, which is -1, when we mix it, we're going to get different chemical formulas. Why? Because when we do the crisscross, 1 and 1 are going to cancel out. So we're going to get copper chloride. And when we mix 2 and 1, the chlorine is going to get a number 2, meaning that it has a different oxidation. Both of these are copper chloride, which, if you follow, is a naming style, which is metal name plus non-metal name with IDE ending. Okay? So in this case, this is, again, copper chloride. And this is also copper chloride. So how do we actually make a difference between these two? It's very simple. you have to analyze the valence of the original metal that we used. So for this formula we use +1, and for this formula we use +2. So we're going to add something else to identify, which is, in parentheses, a Roman numeral. So with this Roman numeral we know the valence of the metal, and we put it between parentheses. That's why I left some space here. And this is going to turn into what? Copper 1 chloride. And this one's going to turn into copper 2 chloride. Just in case you missed it, let's try that once again with a different metal now and with a different non-metal. We're going to choose iron in this case. So we have iron, which can be +2. Where am I getting these numbers from? From a table. Your teacher or somebody should provide you, or you can download a table from internet. And that's it. And that way you know the different oxidation states or valence numbers for the metals, right? Especially transition metals. And we're going to choose another anion, which is bromine. Bromine is -1. Bromine is -1. So once we do the crisscross, what are we going to get? We're going to get iron, bromide, but this 2 comes down here. And then in this case, we're going to get iron, and this 3 comes down here. We don't write the 1. 1 is implicit. And both of these compounds are going to be iron, bromide. And again, how do we differentiate between these two compounds? We have to know what is the original valence of the metal that we used to create the formula. In this case it's 3, in this case it's 2. So this one is going to be iron 2 bromide, and this is going to be iron 3 bromide between parentheses. And this is how you name metals with multiple valence. Let's do a quick reverse example of this. Let's say I write something like tin 4 iodide with its IDE ending, just as I showed you here, IDE ending. Tin iodide, and we want to create the formula. We look for our chart and we know that tin is symbol SN. If it's a 4, that means that it's a +4 here. And if it's iodine, it means we took iodine with a -1, and then our formula after we do the crisscross is going to be SnI4, meaning that this is tin 4 iodide. Okay? Now, to make things a little bit more complicated, and as I said, it's important to watch this video so that you can name all the different compounds that use metals, because these same rules apply. This is modern naming, or it's also called stock system, but when we use what we call classic names, many metals have their original classic name. So we're going to substitute these names for the cation. And for the classic name, what we're going to use is, for the lower valence, we use the ending us, and this is going to be called cuprous. This is very common, especially for copper. Cuprous chloride. And you can also find this in a chart, or you can take some notes in a chart, or you can take some notes, or you can find it on internet as well. And then copper 2, which is the higher valence, is going to be called cupric oxide, cupric chloride. And we have this ic ending and this us ending. In this case, iron also has a low valence and a high valence. So in this case, the low valence is going to turn to us, and the higher valence is going to turn into ic. So in this case, the Latin name for iron is ferrum. Ferrum. The Latin name for copper is cuprum. So that's why this turned into cuprous and this turned into cupric. So in this case, iron is going to turn into ferrous. Ferrous what? Bromide with the IDE ending. And in this case, the higher valence, which is 3, it's going to turn into ferric, ICE ending, bromide. And again, that's stock system versus classic names. One last example, just so that we can really solidify this knowledge. And let's try it with lead. Lead is also quite a popular metal. So lead, there's lead +2, there's lead +4, and I'm going to use another nonmetal, which is going to be, let's try sulfur for the nonmetal. Sulfur is -2. Sulfur is -2. We create our formulas first and we do the crisscross. So Pb2S2, we cancel out the 2's, we get PbS. Pb2 S4. This can be reduced further. We lose the 2. This becomes 2. So PbS2. These are two different types of compounds, even though they come from the same metal. So if we use, again, stock or modern system, the formula, as I said before, is metal name plus the Roman numeral, because this metal has multiple valence, non-metal ending in "ide." So this is going to be lead sulfide with IDE ending. This is going to be lead sulfide as well. However, the valence that we use for this compound is number 2, so this is going to be called lead 2 sulfide, and this we use number 4, lead 4 sulfide with its ending. When you use classic names rely on the original name of the metal, in this case lead. That's how we call it in English, lead. Its Latin name is plumbum or plumbum, depends on your pronunciation. Plumbum, plumbum. That's why the symbol is Pb. So remember, lower valence turns into ending us. So this is going to be plumbus. And the anion did not change, so this is still plumbus sulfide. And on the other hand, for the higher valence, we turn it into ic. So it's going to be plumbic or plumbic, ic sulfide. And that's it. And just another refresher, remember, if you're using metals that only have one valence, we only use modern system. A quick example would be silver. Silver is only +1. We mix it with sulfur, again, -2. We do our crisscross, Ag2S. The metal name is silver. Since it doesn't have valence, we don't use a Roman numeral. Silver sulfide with IDE ending. And again, this applies to any compounds where we have metals. Okay? Good.